What's up guys, welcome back to our channel. In this video tutorial, we are going to discuss about the code implementation of a posterior traversal as well as the inorder traversal. So in our previous video, we have discussed about the pre-order traversal code implementation. So if you have not watched the previous video, you can check out the previous video in the link in the description. And I request you to watch all the videos in a series of my tree series, Shivaya's tree series. So make sure you have bookmarked that series. So let's get started. So in this video tutorial, I am going to discuss about the how to find out the posterior traversal, what logic we will use, what recursive logic we will use to find out the posterior traversal as well as inorder traversal. So let us take a binary tree. Again, for your kind information, I will tell you that I am taking ordinary binary tree. I am not taking a binary search tree. Okay. So let's take a binary tree like this. The right children of 1 is a 3 and let's take the left children of 2 as a 4 and the right children of a 2 as a 5. Let us suppose this is a binary tree. So we have already discussed about the pre-order traversal. So what is the rule is, in case of a pre-order traversal, first we go to the root. Let me write it again. First we go to the root, then we go to the left, and then we go to the right in case of a pre-order traversal. Now in case of a post-order traversal, what we will do, it will be like a opposite of the pre-order traversal. That means, first of all, here post means after. So what we will do is, first of all we go to the left, then we go to the right, and then finally we will come back to the root. Clear? So after traversing the left part, after traversing the right part, we come back to the root, and this type of a traversal is known as a post-order traversal. So let us discuss about the post-order traversal of this particular one. If I talk about the post-order traversal of this, first of all I will go to the current root, because every type of a traversal when you start, it will start from the root node. So what is the current root? That is the 1. So according to the rule of the post-order traversal, first of all I will go to the left part of this. So let's move to its left part. I go to its left part. Again the current root is a 2. So what I need to do is, I need to go to its left part according to the rule of the post-order traversal. So let's move to its left part. I move to its left part again. Again, if you can see, 4 is my current root. What I need to do is, I need to move to its left part. So let us move to its left part. As you can see, there is nothing present in its left part. So this is a base condition. What I need to do is, I need to simply return here. So now for this 4, I have completed a left traversal. Now go to its right part. So I go to the right part of the 4. Again in the right part of a 4, I got nothing. So what I will do is, I will simply return back. So for this particular 4, I go to its left part, I go to its right part, and now I am at the current node. So what I will do is, I will add this 4 into my traversal, which is my root. So let us add it to our answer, 4. Now if you carefully see, for this 4, we have completed the post-order traversal. Now what I will do is, I will come back to this 2. And now if you see, for this particular 2, I have completed the left part. Okay, I have completed the left part for this 2. Now what I need to do is, I need to move to its right part. So let us move to its right part. When I go to the right part of a 2, again my current root is a 5. So again for the 5, we will apply this rule recursively for each and every node. For each and every node, first of all we go to its left, then we go to its right, and then after that we will go to its current, its particular value will be added to our answer. So for this particular 5, I will go to its left, I got nothing, I come back. Then for this particular 5, I go to the right, I got nothing, I come back. And now the current root is what? Current root is a 5. So simply add this 5 to the answer. So again for this 5, I have completed the left and right traversal and added it to the answer. Now I come back to this 2. When I come back to this 2, if you carefully see, the left part of the 2 is traversed, as well as the right part of the 2 is also traversed. So I need to add this current root, that is 2, into the answer. So let us add it to the answer. So this is added to the answer, and then I come back to this 1. Again, if you carefully see, for the 1, I have traversed whole the left part of this one. Now what I need to do is, I need to traverse its right part according to the rule of post-order traversal. So basically I do what? I will simply go to its right part, and when I go to its right part, there is a 3, and again it is a current root. I will go to its left part, recursively for each and every node I need to do this. I got nothing, I come back. So again I go to the right part, I got nothing, I come back. So now the current root is 3, which is added to the my answer. So let us add it to the answer. And in the finally, if you can see, what is the, when I come back from this 3 to 1, for the 3, the left traversal has been completed, the right traversal has been completed. Now the current root, that is the 3, will be added to my answer. Sorry, not a 3, that is a 1 will be added to my answer, because for the 1 I have completed the left traversal, for the 1 I have completed the right traversal completely. Now I need to add this 1 to the answer. So after adding this, the traversal will look like this: 4, 5, 2, 3 and 1. So this is how we calculate the posterior traversal. Similarly, if I talk about, let me explain, write the again here. So let me show you. So if you can see, let me explain now the in-order traversal. So in case of in-order traversal, what I need to do is nothing but in case of in-order traversal, let's suppose this is a tree, 1, 2, 3. I'm taking the same tree I have taken in the previous example of explaining the concept of a posterior traversal. Here I have a 4, and here I have taken a 5. Is it clear? So sorry, let us now discuss about the in-order traversal. So in case of in-order traversal, what we will do? In means between. So first we go to the left part. First we move to the left part. After traversing the left part recursively for each and every node, we go to the current root. We access the current root, and then we go to the right part. Okay, so you have to remember these 3 lines in case of what we do in in-order, pre-order and post-order. Simply there is a quite change, and first we go in case of in-order traversal, first we traverse the left part, then we go to the root, and then we go to the right part. So this is the main method of doing the in-order traversal. So let us see how we will do. Let me write it. So first of all, I will start a traversal for each and every case, every tree we are traversing. We will start a traversal from what? We will start a traversal from the root node. So I will start a traversal from this node. This is current root. First of all, according to the rule, I need to go to its left part. So let's move to its left part. When I come to its left part, as you can see, there is a 2. There is a 2. So when I come to the left part of it, I have a 2. Again, it is a current root. I need to move to its left part again. So let's move to its left part again. Okay, so again I come back to 4. So again, if you can see, I am at the current root, that is a 4. According to the rule, again I need to go to its left part. As you can see, there is nothing present in the left part. So what I will do, I will simply return come back. Now left part is completed for the 4. Now the current root will be added to the answer. So let's add it to the answer 4. Clear? And now I need to move to the right part according to the given question, according to the pre-order traversal rules, in-order traversal rule, sorry. So there is also nothing, so I come back. When I come back, final recursion go back to this particular one. So as you can see, for the 2, we have taken its left part. Now the current root 2 will be added to the answer because we have taken its left now. So we have to add 2 to the answer now. So let us add it to the answer 2. And now I need to move to its right part. When I go to its right part, again 5 is my current root, if you can see. So I need to go to its left part. I got nothing, so I come back. Now 5 is my current root. I add it to the answer, and I go to its right part. I have nothing, so I come back. So there is nothing, I come back here. So again, if you carefully see, this whole tree has been traversed. So what we need to do in an in-order traversal, for each and every node, first of all, we are traversing its left subtree. After that, we are coming back to the current node, and then add the current node to the answer, and then we are traversing its right subtree. We need to do these steps recursively for each and every node. Okay, so I now come back from this 2 to this 1. If you carefully see, for this 1, the left subtree has been traversed. Now I need to add this current root, that is 1, to the answer. So let us add it to the answer. So I have added it to the answer. So after adding it to the answer, what I will do is I will move to its right part. Again 3 is my current route. I will move to its left part. I got nothing. So I come back from this part to this part 3. So because 3 is, I come back for 3. So 3 will be added to the answer because it is a current route. After that I will go to the right part. In the right part I got nothing. So I come back. Finally the recursion goes back to here and program exits. So if you can see, in case of in-order traversal, what we are doing is, first of all we are going to the left part. Okay, after going to left part continuously, we are accessing at any point where we get a null value, we will be returning back. Okay, we will be returning back. So when we return back, whatever the value of a root, we will add it to the answer, and we will make sure that the recursion should be sent to its right. So first of all we will go to the left, then we access the current route, and then we will go to the right part. So if I discuss the code part of this, if you can see, in case of a pre-order traversal, what we have done is, first of all, whatever the value of a route, because in case of a pre-order traversal, what we have done is, first of all we go to the root, then we go to its left part, and then we go to its right part. Here what I have done is, first of all I have taken a route to data, I have printed the route to data, then I have called the pre-order traversal for the left part. So recursion is sent to the left, and then pre-order traversal is sent to the right part. When this recursion call is completed, I will traverse the left subtree. So first I have taken the route, then I have traversed the left part, and then I have traversed the right part. And there is a base condition that when the route is equals to null, what is that base condition? Basically is like this one. As you can see in the leaf nodes, I have nothing in the left or the right field. So in that particular case I need to return. So then I will simply return to the previous stack frame. So what I will do in case of a post order traversal. So let us write the code of a post order traversal. So in case of a post order traversal, first of all I will start from the root. So in case of a post order traversal, nothing will be changed. First of all let us write the base condition. If root is equals to null, then I will simply need to return. And in case of a post order traversal, what we are doing is, first of all we are going to the left part. So this line will be written first. Okay, so I can say that post order traversal, in which I will part root to left, and then I am going to right. Okay, so in a post order traversal, first of all we traverse the left subtree, and then I will traverse the root to right subtree, and then finally I will print the current value of the root. Okay, so this is, sorry, root to data, whatever it is. I hope you understand. And what will be the code of in-order traversals? First of all let me discuss the code of a post-order traversal. What we have done here, see, first we have sent the recursion in the left part, then we have sent the recursion in the right part. After that, left subtree and right subtree is completely traversed. Whatever the value of a current root, I have added it to the answer, or I have printed it. So in case of in-order traversal, what will be the change? This will be same for in-order traversal. The only change will be, first of all I will go to the left, then I will access the root, and after accessing the root I will go to the right subtree part. So let us write the code of the in-order traversal also. Void in-order traversal. Okay, so again the base condition is, if root is equals to null, then we need to simply return. Clear? Then we need to simply return. You might ask a question about, I have not used a curly parenthesis here. So for your kind information, maybe you know, but whenever we are having a single statement in any of the if else or any loop, we can simply write it without using a curly braces. Okay, so let us discuss the in-order traversal. First of all we will send the recursion to the left part. Then after a recursion is completed in case of a left part, we will simply print the current route to data, and then we will send the recursion to the right part. So if you are willing to understand what I have done here, recursion, how recursion works, so make sure you have watched our previous video. In that particular video I have explained all the concept regarding a pre-order traversal, and if you understand this concept in previous video, if you understand the previous video, then it is very easy for you to understand how these algorithms is working. So in case of a pre-order traversal, first we take a route, here we take a route, send recursion to the left, and then send recursion to the right. In case of a post-order traversal, first of all we send the recursion to the left, then we send the recursion to the right, and then we take a route. In case of in-order traversal, first we send the recursion to the left, then we take a route, and then after that we send the recursion to the right. So I hope you have understand all the concepts regarding the binary tree and traversals. So make sure you have subscribed our channel and also press the bell icon. So I will be completing this series with also the important questions. So meet you next video. Till then, bye bye.